Welcome to the solutions to the Regents Physics Waves and Sound problem set. Problems number 17 through 20. 17. A common method of estimating how far a lightning flash is from you is to count the seconds between the flash and the thunder, and then divide by 3. The result is the distance in kilometers. Explain how this rule works, and then what would be the rule in miles. What this question is addressing is the marked difference between the speed of light and the speed of sound. Looking at your reference table, the speed of light in a vacuum, and quite frankly to 3 digits also in air, is the same as 3.00 times 10 to the 8th meters per second. The speed of sound in air, STP, is nearly 330 meters per second. So you see that the numbers are essentially almost the same, but the power of 10 difference is remarkable. With speed of light being 10 to the 8th and speed of sound being 10 to the 2nd. That's a 10 to the 6th difference, which is 1,000,000 times in difference. So speed of light is 1,000,000 times faster than the speed of sound. That's why we see the flash events often that are far away and then hear them afterwards. For the English system, the rule in miles is that if you hear 5 seconds between the flash and the thunder, that lightning is 1 mile away. So 5 seconds of time gives you a 1 mile separation between you seeing the lightning and hearing the thunder. Number 18, the speed of sound increases by about 0.60 meters per second for each degree Celsius when the air temperature rises above standard temperature and pressure. For a given sound, as the temperature increases, what happens to the frequency and the wavelength? This is kind of a refraction question in that the sound wave changes medium as the air temperature increases. And the reason for that is that causes a change in speed. Our rule of thumb for refraction is that all wave characteristics change except frequency. And by the way, they change the same. More to come on that as we investigate refraction in the lab. So we know that as the temperature increases, the speed increases. That as you change medium, the frequency is not going to change. So applying V equals F lambda, V and lambda have a direct relationship without F changing. So as velocity increases, so does the wavelength. The wavelength gets longer. 19. Suppose the horns of all cars emitted sound of the same frequency, which the human perception of which is pitch. How would you perceive the change in frequency of the horn of a car moving toward you and away from you? This question is addressing the concept of the Doppler effect. We will be having a totally separate lesson on this in class, but you know and have experienced the Doppler effect for sound. You just may not realize that you have. So, what do objects that are emitting sound like as they're coming toward you as compared to when they're going away from you? Well, compared to the actual frequency of the sound, the Doppler effect causes a shift in the apparent frequency of what you hear. And the human perception, as we just mentioned a moment ago, the human perception of frequency is pitch. So as objects travel toward you, you perceive an increase in frequency from the actual frequency that's being given off by the horn. And this would cause an increase in what you hear as pitch. The moment the horn is now going away from you, you would experience a decrease in frequency. And that's an apparent shift, not an actual shift. And this would cause a decrease in pitch. This gives you the the stereotypical race car noise that most people associate with the Doppler effect. More to come on that in class when we do that Doppler effect lesson together. Number 20, if the pitch of a sound is increased, what are the changes in its frequency, wavelength, velocity, and amplitude of the wave? Well, pitch of a sound, as we just mentioned a moment ago, is an indication of our perception of frequency. So if the pitch is increased, that means the frequency increases. We're not changing the medium, so we actually have to answer C first in order to get this question for B. We're not changing medium, so we're not changing speed. And applying the wave equation, V equals F lambda, with an increase in frequency, and since speed is the product of frequency and wavelength, the only way for the velocity to remain constant with an increase in frequency is if the wavelength decreases. So our frequency increases, our wavelength decreases, while our speed remains constant due to no change in medium. The amplitude of the wave? The amplitude is an indication of how much energy the wave is carrying. And nowhere in here did they mention a change in energy, so there's no change in amplitude. And by the way, the human perception of that for sound would be loudness. A louder sound is carrying more energy, and therefore that sound wave would have greater amplitude. All right, that'll do it on questions 17 through 20. More to come in class as we investigate problems 21, 22, and 23 together in class tomorrow.